We don't know enough about the impact of nanomaterials on the environment. It's a new technology, whose full implications are yet to be revealed. You could fit as many nanoparticles in a football as you could fit footballs in the planet Earth. That is, they are 1,000 times thinner than a human hair. This fact makes it difficult to fully understand their impact on the natural environment, especially given that there are also naturally occurring nanomaterials present in the mix. Nanomaterials in mesocosms, a needle in a haystack. Until a few years ago, the effect of nanoparticles on the environmental media of exposure was defined and discussed on the basis of their manufactured form only. Today, we know that before appearing in the environment, many nanoparticles, including nanopesticides, undergo transformations in wastewater treatment plants and reach the environmental compartments with significant transformations. To understand the impact of these transformed nanoparticles on the natural environment, several research entities, led by the Natural Environment Research Council in the UK, have developed an innovative and creative project that they call the NanoFase project.
The Horizon 2020 project NanoFase deals with the fate and speciation of nanomaterials in the environment. In this way, the life cycle of nanomaterials is assessed, aiming at understanding transformations that may occur in the different environmental compartments that may act as a reactor. These reactors may be an aquatic or terrestrial ecosystem, but also a living organism.
After ingesting nanomaterials, organisms can also induce several transformations. From dissolution to the formation of a corona that will incorporate biomolecules in the nanomaterials. These uptake and elimination processes and related kinetics have already been studied in the laboratory. And the next step will be to validate the results in more realistic scenarios. To achieve this, the University of Aveiro research team and partner in the project was responsible for the mesocosm experiments. An aquatic mesocosm was designed to simulate a river system where effluents incorporating nanomaterials may be discharged. A second one, a small-scale terrestrial mesocosm, will simulate the potential entry of the disposal of nanomaterials from wastewater biosolids to soils. The multi-species mesocosm experiment bridges the gap between the laboratory and real environmental scenarios and requires a complex experimental design and a specialized and dedicated team of researchers. So, as one can imagine, this brings together a special request for several areas of expertise, from biology to physiology, from ecology to physics and chemistry, and a straight collaboration between all experts. The complexity of these mesocosms also makes their implementation complex, in addition to the expertise complexity.
These mesocosm experiments bring some novelty regarding the approach carried out. So we aimed at evaluating the fate of nanomaterials in organisms, how will they accumulate and eliminate these nanomaterials, and the formation of ecocorona, or even the internalization in biota, accounting always with the interaction between species. In addition, the fate in the physical compartment, so the soil, the water or the sediment, were also evaluated to understand how exposure was carried out.
In the aquatic mesocosms, organisms belonging to different trophic levels and ecological niches of river ecosystems, like mosquito larvae, planaria, aquatic snails, oligochaetes, daphnias, fish and biofilm, were exposed to silver sulfatized nanoparticles. To obtain biofilm samples for the experiment, the researchers had to collect the plaques placed a few weeks earlier on a stretch of river where the biofilm had associated. Invertebrate specimens were collected from laboratory cultures, and daphnids were used to feed fish in the mesocosms. The terrestrial mesocosm soil, previously contaminated with silver nanoparticles, received organisms with different ecological functions. Plants, isopods, beetle larvae and earthworms were exposed to the contaminated soil. At different sampling times, replicates of terrestrial and aquatic mesocosms were randomly targeted for destructive sampling, and the organisms sampled were stored for further analysis. From this stage, the various partners of the NanoFase project and experts from the different research areas will jointly analyze the samples. Data obtained will be used to validate standardized or well-described bioaccumulation tests with single species, and to predict in a more accurate way what happens to ecosystems and organisms when exposed to silver nanoparticles.
NanoFase project brought together several expertise and experts with the final goal of building a clickable exposure assessment framework that can be used by different stakeholders, from academia to industry, governance and regulation.
This clickable framework can already be trialed on the NanoFase webpage.
you.